On part 2, we're going to be taking a look at finding points of horizontal and vertical tangency for the graph. Now, let's say we forgot how to get the derivative. So if I want to find the derivative, dy dx, remember this is just the derivative of the y value, and that's r sine of theta over the derivative of r cosine of theta. And if I simplify this, it's just very simple. It's just product rule. The first times the derivative of the second plus the second sine of theta times the derivative of the first, which we call r prime. On the bottom, same thing, product rule. The first times the derivative of the second becomes negative sine of theta plus the second cosine of theta times the derivative of the first, or r prime. So this is one that I don't have to memorize as far as the formula. I can derive it every time. You just got to remember r sine of theta is y and r cosine of theta is x, which should be pretty easy because if you remember in part 1, we derived that from just the right triangle. So not too hard to do here. Now, you got to remember though, we do need r, which is 2 minus 2 cosine of theta, and we need r prime, which is just going to be 2 sine of theta. And we plug it in. So my derivative becomes 2 minus 2 cosine of theta times the cosine of theta minus r prime 2 sine of theta times the sine of theta. On the bottom, negative r, so negative 2 minus 2 cosine of theta times the sine of theta plus r prime 2 sine of theta cosine of theta. R prime reminds me of an Autobot. Didn't have much power though. Mathematicians, you know. Alright, so now I'm looking for horizontal and vertical tangencies. So we should remember to get a horizontal tangent, we set the top, or dy, equal to 0. So I set my entire top equation equal to 0. Now I'm going to do a little bit of algebra here. I'm going to distribute. That gives me 2 cosine of theta minus 2 cosine squared of theta minus 2 sine squared of theta equals 0. Now I can divide everything out by 2. And that gives me cosine theta minus cosine squared theta minus sine squared of theta equals 0. Oh no, that should be plus. Sorry, my formula should be pluses right there. Plus, plus. Please fix those, okay? Mistake on my part. Copy error. Now, over here, I have to convert cosine in terms of sine or sine in terms of cosine, and in trig, majority rules. So we're going to change the sine squared in terms of cosine, which is easy. So we get cosine of theta minus cosine squared theta plus, this is just 1 minus sine squared of theta. Rewriting it, I get 1 plus cosine of theta minus 2 cosine squared of theta equals to 0. And now we're going to factor. This one's not too bad. 1 cosine cosine. I'll give this one the 2. And so I want positive cosine, so that's positive, and there's my negative. So we get the cosine of theta equals negative a half, and we get the cosine of theta equals 0. Well, where it's equal to 0 is easy. That's just 0. We'll talk about that one in just a bit. But where is theta equal to negative 1/2? Well, cosine is equal to negative 1/2 in the second and second and third quadrant. So that's going to be our 2 pi over 3 and 4 pi over 3. We do want the angles here. So we'll get so we do want to get the angles here. Sorry about that, somebody's at the door. So we have to solve for r here. Now we do know what r is equal to. Sorry about the pause, somebody's at my door. So we get 2 minus 2. The cosine, I'm going to use the 2 pi over 3 this time. And that becomes this negative 1/2, so that gives me 3. So I'm going to get a point. So my first point is going to be 3 2 pi thirds r comma theta. To get the next one, I plug in 4 pi over 3. 2 minus 2 times 4 pi, the cosine of 4 pi over 3, which is negative 1/2. Again, which is negative 1/2, and again I get 3. Sorry about that. The math is wrong, but the number is right. So the cosine of 4 pi over 3 is negative 1/2, so I get 3 again. So my other point is 3, and I get 4 pi over 3. So what it's telling me if I were to graph this cardioid, that's what this is, a cardioid, at 4 pi over 3 and 2 pi over 3, I would have horizontal tangents. So let's talk about 0. When I plug r of 0, when I want to find 0, I get 2 minus 2. Now the cosine of 0 is 1, which gives me 0. My radius is 0. Well, if we think of the shape, this is a cardioid along the x-axis facing to the left. So it's going to look kind of like this if we were to graph it. Now, it's saying at this point, do we have a horizontal tangent? No, it's a cusp. We got to recognize it. So we don't accept r equals 0 as a horizontal tangent because it's not a horizontal tangent. There's a cusp there in our cardioid. So really, anytime we have a radius of 0, we don't accept it. Now, to get the vertical, we do the same thing. Hopefully, we do the same thing. So to get the vertical, except for this time we let the bottom be 0. dx equals 0. And again, I'm going to simplify this just a little bit. This gives me negative 2 sine of theta plus 2 sine theta cosine theta plus 2 sine theta cosine theta equal to 0. Cleaning up a little bit, negative 2 sine of theta plus 4 sine theta cosine theta equals 0. Now notice I did not write this as sine of 2 theta here. And the reason for this is because now I know I can factor out a negative 2 sine of theta. It does make it a little bit easier sometimes. And that's going to give me 1 minus 2 cosine of theta, which equals 0. So I'm going to find out where sine of theta equals 0 and the cosine of theta equals 1/2. Well, sine is 0 at 0 and pi, and cosine of theta is at pi over 2 at is 1/2 in the first quadrant, that's pi over 3, and in the fourth quadrant, 5 pi over 3. So I got 4 possibles here. I got to check them all. So the first one I'm going to pick r of 0, plug it in. I get 2 minus 2. The cosine of 0 is 1. So I get 0 again. And again, remember we said r can't be 0, so we don't worry about that one. So next one, r of pi. So I get 2 minus 2. The cosine of pi is negative 1. That gives me 4. So I have a point at 4 pi. And now I get to the other ones. R of pi over 3. I get 2 minus 2. Well, the cosine of pi over 3 is 1/2. That gives me 1. So I get 1 at 1 pi over 3. And if I do r of, 2 pi over 5 pi over 3. Same thing, 2 minus 2 times 1/2. I get 1. I get 1 5 pi over 3. And there it is. Now, if you take a look here, again, it can't be a 0 because it says, again, it can't be a 0 here because of the vertical rule. That's not a vertical rule. It's a cusp. It doesn't exist, but it's not. It's a D and E, but it's not vertical. It's nothing there. So, ready? How many horizontal tangents do we have? Well, where's the slope 0? Here and here. So we expect to get 2. How many vertical? Count. 1, 2, 3. Well, there's my vertical right here. Here's my vertical, and here's my vertical. So we do get 3 vertical tangents. Alright, so that's the end of part 2. So I hope you guys had fun, and I'll see you guys later. Bye-bye.